So does anyone have any questions? I am only missing about 15 people. I almost have 2/3 of my people here. Not sure how to feel about that. Oh, hey, somebody else just came in. Anybody, any questions on homework that you are definitely working on? So here's a little thing I want to remind you guys about. What do our homework corrections do again?
Day of the final.
Day of the final. So guess what your main priority should be?
New homework.
New homework. You want to keep up with new homework and do the old as you get time. So if you have very limited time, you keep up with new homework. That is your main priority. Because you all know getting behind on that homework it'll kill you. It hurts. I want to show you two things that I've added into Canvas. Why are you doing this to me? There you go. Right up here, I can't remember if I told you about this. I'm adding in some, so we always have office hours right before class. So from 5 to 5:30, I'm on Zoom. That's why the link starts at 5. But if you can't come to those, I've set up these times every week starting tomorrow. Or what is today? Yeah, starting tomorrow. Thank God. Today's Wednesday, right? Yay. All right. So starting tomorrow. And so this link, these links in here, there's the Tuesdays link and there's the Thursdays link. They'll work every Tuesday or every Thursday. They'll work. You guys with me? And so Tuesdays 12:30 to 1:30, Thursdays 2 to 3. If you want more time besides 5 to 5:30 and these don't work for you, just email me. And I've set up times with people individually or little groups or whatever. Any questions on that? Yes, Brian.
Yeah, I have a question. What are those phone numbers for again?
If you want to phone in to the meeting.
Oh, the Zoom meeting?
Yes, if that's all you can do. So this is if people still want to go in there and ask questions, but suddenly their what do you call it? Their Wi-Fi goes down. You can actually use a phone number.
All right, bet.
Is that right?
Yes.
You're welcome. Whatever I said, Jason. You're welcome. Let me see. Oh, and then here's the other big thing. So if nobody has questions on homework, we're just going to jump right in. And the nice thing is, the first thing I'm going to do is what I said I was going to do, which is I have put up here also, if you can go into Canvas right now, you see, not the quiz. See, here's unit 0, 1, 2. That's the old stuff that you've already all finished, all of that stuff. Of course you have. And then here's something brand new, unit 3. And I'm going to keep doing this unit 4, unit 5. So whenever I put a handout, worksheet, whatever, I'll put it up here. The turn-in homework stuff will always be at the bottom, the modules for that. So you can just scroll all the way to the bottom if you need to turn homework in. So if I click on this, I get this little worksheet. Woohoo! So that's what I want to do right now. That's what actually I'm going to sit here and wait for you to do it. So if you have access to Canvas, go there now. If you don't, let me pull this up in a little bit better. Is this the same thing, Jeff? No. Let me find it real quick. This is another sheet I'm thinking about using eventually. That is interesting. Oh yeah, I just forgot to change that. That's right. Okay. All right, so let me share this with you guys. So again, if you can get it to Canvas, go into Canvas and get that sheet. Otherwise, here, I will share this with you. And I want you to work on this. And then I'll break you up into teams. You guys can work together, and then we'll work on it together, get it done, and then we'll keep going. So everybody should be working now on stuff, hopefully. This is always so weird for me. I think I could probably pause the recording. So most of the rooms were working together. I think one room was mostly chatting with each other about the answers. That's good. And then a couple of rooms were not doing shit. We got to work on that. So let's look at this thing together here. All right. So you guys should be able to see this sucker now. Let's see. This kind of sucks when I do it like this, but too bad. It's just the way it's going to be. So this first question. So nobody had any questions about number one, which is encouraging because number one shouldn't have been very, very challenging at all. Is it a one-to-one function?
Yes.
No. Ooh, I got dissension. Did somebody say yes?
Yes.
Yes. Did somebody say no? Nobody wants to say no? So it is definitely not a one-to-one function. Does anyone know why? What's happening? You guys all right out there?
Sorry. It's not a function because when you do the horizontal line test, it hits several points at one time.
And let's be careful. It is a function. It's not a one-to-one
Oh,
function.
sorry, yeah.
So yeah, if I draw, all it takes is one horizontal line, pretend like that's horizontal. If it hits more than once, it is not one-to-one. 11. So no. Why or why not? The horizontal line test. Bam. All right. What's the domain?
-8 to 4.
Yeah, because the first place I see is -8, and then the last place I see it is at 4. I love it. And that's, of course, while I'm walking across the x-axis. And then what's the range?
-7 to 2.
Yeah, the lowest I see is -7, and then the last time I see it is at 2. Kick ass.
Would that be in parentheses or brackets?
Why is it brackets? The parentheses would mean that, like if I put a parenthesis on -8, that would mean that that input doesn't have an output. But it does. So if this was an open circle here, then that -8 would have been the parenthesis. Oh shit, I didn't mean to actually put it there. Dadgummit. Arf. All right. Ha! All right, sweet. Sorry. Is that all right with everybody?
Yeah.
Okay. And then f of -6, what's that bad boy?
2.
Totally. Because for an input in -6, the output's 2. That's exactly what that is asking for. Now, somebody I haven't heard from yet. What interval is it? How many intervals is it increasing on?
2.
2. I like it. And the first interval is from?
-6. I mean, sorry,
No.
-8
Gotcha.
and 6.
And -6, right? Because it's increasing from -8 to -6.
Oh, yeah.
And then where's the other place it's increasing from? 2.
1.
1.
1. 1 to
4.
4. And then where's it decreasing?
-6 to 1.
I love it. And see how that fills in the gap here. Pew!
So do you not include the end values, like the dots at the very end of the line, as considered increasing?
Like right here?
Yeah.
The reason I can't is because the idea of increasing is based on where it was, what's it doing as it goes through that point. But at these points, it wasn't doing a damn thing before there. What could it have been doing? It could have done this, right?
Yeah.
So so it looks like maybe it wants to do this, but maybe outside of there, it could have been doing anything. And the fact is, it's not doing anything. It's a void. So the idea of increasing, decreasing is as it goes through a point, what was it doing right before that point, through that point? And if there's no other side to it, it can't be considered. How we doing out there? And of course, we talked about stuff like this one. It's flat there, so it wouldn't be included in either either one of those max and mins. I like it. Let me see if I can sneak this in here, because what is the local max value?
-6, 1.
No, in a
I
couple
mean-
different ways.
2.
2. The value, right? The maximum value. So that's going to be the output. Where does that maximum value occur?
Oh, at -6, 2.
Stop. No, it occurs at -6.
Oh. Oh, okay. Okay.
So the x-axis is kind of like where things happen, and the y-axis is what happens there.
Okay.
I like it. And of course, same thing over here. Local min value would be
1. Oh, no, wait, no.
where it occurs. It occurs at 1.
Yeah, so -7.
Yes, and the value is -7. I like it. There you go. All right, let me stop there for a minute. Is that all right, you guys? This is the kind of problem I love to give. Hint, hint. I'm about to clear this. So I don't know if you're. Is anybody? There you go. Jason, Stellan, Athena. She was right. Good job, Athena.
I can't really see the bottom part.
Where are we at? I'm sorry. Oh, yeah, I'm sorry. Let me tell you what it says, because I can't move it. They're stuck here. Local max value is 2, right there. And it occurs at -6. And the min value is -7. And that occurs at 1.
So on a test, how do you want us to write it?
Like this.
Just literally -7 and then x equals 1?
Yep.
Got it.
Okay, so I'm going to clear this now. It's going to go away. Bye. Okay. So let's look at this. This was our most fun problem. Don't let this domain question be a problem. It's think about in English what can't happen in this kind of problem. The bottom can't be
0.
0.
and then you solve it so x can't be -5. So that is actually a really concise, good Lord, Jeff, really concise way to write the domain of this. You could write it in interval notation, but to me it's stupid because it requires so much more writing. This is much more concise. Everything except -5 works.
So is that an acceptable way to answer that problem then?
Yes. And what about g of x? How do I figure out g of x's domain? What must happen here?
3x plus 10 must be greater than or equal to 0.
Exactly. Because the implied thing, when I just say domain, I'm implying real numbers. If I needed to say, if I wanted complex numbers to be okay, I'd have to say that. Domain over the complex numbers. I'd have to say something like that. Otherwise, it's understood to mean real numbers. And when you solve this, you get x greater than or equal to. Nobody's going to help me out. Okay. Look at that. If I don't look, I make a great 3. I love that shit. So this one definitely tripped people up, but we talked a little bit about this last time. This is just a quicker way to write f of 5 divided by g of 5. So what did somebody get for f of 5? When you plug a 5 into this, what do you get?
19 over 10.
19 tenths. And then what do you get when you plug a 5 into g?
5.
5. I love it. So what's 19 tenths divided by 5?
19 over 50.
Yeah, 19 over 50. Kick ass.
Hmm.
You guys all right with that? That was an interesting sound effect there. Because 19 tenths divided by 5 is 19 tenths times 1/5.
Ah.
Another way to look at this is 19 is being divided by 10 and also divided by 5. So of course it's being divided by 50 total. That's kind of another way to see that. Is that all right? I love you guys. You're all like, just say it's okay so he'll just stop. Is that all right? All right. And then this one, I was really hoping wouldn't have been that big of a deal. You just plug a 3W in for X. So here you get 12W minus 1. And on the bottom, you just get 3W plus 5. And there's a special place. I could either say in my heart or in hell for anybody who reduces this. Why can I not reduce these?
Because it's addition?
Yes, division cannot cancel parts of subtraction or addition. That is beyond its ability. Right? Okay. Nobody out there says, well, my division is strong, Joe. Be quiet. Your division's everybody's division. This is what we talked about recently. It's really just a reformulation of the slope, because that's all average rate of change means, is slope. Good. I love this shit. I mean, I'm back in 3rd grade. Look at me. Look at what I can do, teacher. So I would do f of 2 minus f of negative 2. This is frustrating for me. It must be exciting for you guys. Over 2 minus negative 2. This poor little problem, it needs a lot of its own room. So I'm gonna erase this before I do part E anyway. So what's f of 2? This comes out nicer than you would think if I did this right. What is f of 2?
1.
Yeah, 1. You'll get 7 over 7. What is f of negative 2?
Negative 3.
Negative 3, right? Dang it, when I try, I make horrible 3s. All right. And then over the bottom, of course, I get 4. So I get 1 plus 3 over 4 is 1. Crazy shit. I am drawing with my mouse. I don't have a tablet. I should have a tablet, and then it would only be marginally better anyway. That's all I appreciate. Respect, sure. I don't deserve any for that, but that's fine. I'll take it. Any questions over any of the scribble? This is the literal definition of chicken scratch here. Any questions on that? Because I want to do this guy, and I'm going to erase all this shit so I can do this guy. Maybe I'll erase what's above it so I don't have to erase everything. I'm going to take this away. This should be old news. I don't have to make sound effects, Jeff. All right, so let's look at this one. This is going to be exciting. So g of f of x. So if I plug, this will be 3 times, can I just cut to the chase here? 3 times 4x minus 1 is 12x minus 3. See that? 3's are the bane of my existence. Over x plus 5. This is this one, by the way, right? Is you guys with me? What is it? Plus 10. So I did 3 times this whole damn thing. I got to plug all that shit in there. So I did 3 times the top over the bottom. And then I can just, let me see if you guys are cool with this. I can just make an LCD really easy by giving this an x plus 5. Bam. Let me stop for a minute. Are you guys with me? I mean, it seemed like it was going to be disgusting, but once you write it out, it really is not as disgusting as you thought.
So I have a question now that I'm not screaming into my room anymore. I didn't realize I muted myself a while ago. But why do you not distribute the 3 onto the denominator, just the numerator?
Because when I write 3, so here's 3 times f of x, right?
Mm-hmm.
When I write 3, what's understood to be underneath it?
1. That, okay.
Because if you multiply top and bottom by the same thing, you've done nothing to it. But I'm supposed to be tripling it, yeah.
Yeah. Okay.
And then just to cut to the chase here, this would be 12x plus 10x is 22x. This would be -3 plus 50, so that's going to be 47. Are you guys cool with this? I mean, now that I have LCD, I can just put these things together, and that's basically as far as it can go. Pew, choo, 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 choo. Oh, that was yummy. I know. It's always a little creepy when I say that. And you're like, I don't think you know what that word means, Chef. Okay.
A little.
Say
Would
again?
it be, I have a question.
Yes.
Would it be plus or minus the square root, or would it just be the square root?
You tell me, is g of x equal plus or minus?
No.
And we did not apply a square root to anything. It was there already.
Okay.
The only
you.
time you put plus or minus is if you're the one applying a root. That's the shortcut for not having to do factoring or whatever else, right?
Thank you.
I'm not coming down on you. That's a good question for everybody. That's why I wanted to make a point out of that.
Okay. Thank you.
Sure. All right. Okay. I wasn't really, all right, planning on that. I should have known that was going to take a little bit of time. I think that you guys will not be upset if I end class now. That means that tomorrow we're definitely going to have a full class. We need to try to stay on track. I could do a little bit more right now, but I sense you might be a little bit brain fried. I don't know. Is that true? If I take
Yes.
I think that the leave now is going to win. So does anybody still need this up here?
John, where you got the 10x plus 5 again?
Oh, it wasn't there originally, so... Oh, shit. Don't do that, Jeff. I almost cleared everything. So that's what it was originally, right? I mean, that's just from here, the 10 here, right? Is that all right? I'm going to pretend like that's a yes. Okay. And then the only way I can combine these is if they have an LCD. To give it an LCD, I just give the top and bottom x plus 5.
Okay, I understand.
Cool. I like it. So one thing you need to learn, and I'm going to keep trying to stress, is that the basic ideas of things cannot change. That is a fundamental aspect of math. We learn more things, we learn more functions, but the basic ideas do not change. It just gets harder to work with the parts of something, but the process for the whole thing does not change. Anytime you think that, oh, now we're doing it this way and we used to do it this way, you stop and you talk to me because you're not looking at something right. Okay. All right, let me see. I'm going to stop sharing now. Hopefully everybody's got, you probably got more than you wanted to from that. So that's probably enough. Bam. So one last thing I want to do before I let you out of here. Right? Whoa. Can somebody check your messages without me having to hear it? Just want to look ahead a little bit. So in section 3.5, we're going to talk about what's called transformation of functions. So this is why you desperately need to know the shapes. I pointed out that they keep bringing the shapes back. The shape of a radical, the shape of a parabola, the shape of a cubic, because we're going to start moving those things around, shifting them around. So that's one aspect of transformations is just shifts. There's also reflections. There's also compression. Like I could take a parabola, make it skinny, or I can make it fat, right? And we need to know what does that look like in the equation to make that happen, to make it open up or close a little bit. There are definite things we could do to equate to functions to make that happen. So that's what this whole thing is about. And then 3.6, we basically already did 3.6, which is nice. I kind of did a little preview and already talked about most of what 3.6 talks about. And then 3.7 is finally inverse functions. That's what the one-to-one thing tries to see, is if an inverse function exists. So we should certainly be able to do all three of these on tomorrow night, and then maybe even look a little bit ahead. And chapter 4 should be relatively easy with linear stuff, but we'll see. There might be a little bit of weirdness with some word problems in there. Oh yeah, word problems coming. All right. Otherwise, I think that's enough. Let me know if you have any questions. You can hang out and ask. Otherwise, you may go. Grab a beverage or not. It's up to you. Free go.
Thank you.
You're welcome. Are you guys, anybody have a question, or are you actually not? Oh, here we go. People are leaving. Good night. Let's see, is Josh. Yeah, good night, Josh.
I have a question, Professor.
Yes.
For number 2, for part A, what if the bottom part is x plus 5, but if it were to be x minus 5, it would still be 0, right? You can't have 0 in the denominator.
Yeah, that idea doesn't care what's down there. That's an
Okay.
idea just by itself. The bottom can't be 0.
Okay, and then
Yeah,
go ahead.
I was going to say, whatever's in the bottom makes the equation that comes out of that harder or easier to do, but the idea of not equal to 0 stays.
It stays the same.
Yeah.
Okay, sweet. Yeah, because I was like, well, what if it's a negative? You know, does that a rule apply? You know?
Yeah.
Okay.
So if the bottom was like x squared minus 3x minus 15, whatever the shit, then you have to factor and all, and then you got more work to do. But the idea of not equal to 0 stays the same.
Okay. Alrighty. Yeah, that makes that clarifies better.
Sweet.
Thank you.
You're welcome. Charles, Melissa, Guanglu, are you guys there?
Yeah, I'm here.
Do you have questions?
So on 2B, I kind of messed that one up. For some reason I did fog a 5 instead of
Oh, I see.
G, so it definitely threw it off.
That
But
actually made it easier, though, didn't it? I mean,
oh yeah, it did, but it wasn't.
it wasn't right, though. Yeah.
Yeah. But for E, where it says G of f of x, if that was G of f of 5, then you would use Goff.
Goff.
5.
Then
Yeah.
you would have done f of 5 and then plug that into G. Exactly.
Okay, just making sure.
Oh, yeah. Yeah.
Right, thank you.
No worries. Let's see. Melissa, are you okay?
I was just going over 2E because I saw a different answer from what I got at the end. It was just me. It was short circuit. It was just at the end, the 22x plus 47. I did it wrong, so I got plus 12 instead of 47. I was just trying to figure that out, so I was rewriting it, but I got it now. That was it.
Oh, you got it. Okay, good. All right. Sweet.
All right, well, see you tomorrow.
Okay, see you, Melissa.